persistence layers. This is what I'm going to kind of hit in the most topical way, just kind of to talk a little about, modeling data. So persistence is basically any state that lives beyond the process that created it. So you've got database records, you've got file system entities, and you've got cookies. Those are three things that are persistent. There are other things that are persistent as well, but just a few examples. And basically what I want to talk about is how we can logically represent these as objects. So first off, we've got the CRUD lifecycle. For those that aren't familiar, we've basically got four things that we're going to do with anything that's persistent. We're going to create it, we're going to read it, we're going to update it, and we're going to delete it. And so let's objectify that CRUD for the database. So a common pattern used to objectify CRUD in a database is the active record pattern. And basically the idea is that the object represents a record in the database table. It's bound to an existing record or a new record, so maybe a record that doesn't exist yet, it's false ID or whatever, but it's bound to something. And then you go ahead and you implement CRUD interfaces and you do setters and getters. So I'm going to present a bad active record implementation first. So, here's our binding. We just go ahead, we'll pass it a table, we'll pass it a column, we'll pass it a key. You could, of course, extend it and drop in a table as you wanted it or tweak this. Then we're going to go ahead and we're going to have a read and an update. And we're going to set, it's kind of weird, I'm just using kind of a toy syntax here, but essentially we're just making some SQL calls every time that read or update gets called. And then we've got to create and delete that are implemented similarly. So that's bad active record. First problem is we're not using the language system. It's not very elegant because, I screwed this up a little bit, but basically what we want to be able to do is really we just want to say aren't columns just like object properties, right? If we're binding an object to a row, why is it not just an object with properties? Why do we have to call this update function? So instead of calling an update function, let's just go ahead and implement that instead. So what we'll do to do that is just the magic methods. We'll use get and we'll use set. So they're roughly equivalent to what we've already got for our read and our update. But now we're at least using the language system. It feels more like you're working with an object rather than you're calling methods on an object that do something that really is nothing more than property setting. Now basic extensibility. Just kind of an example of what I was talking about in terms of if you wanted to say, well, the user, I want a user model. I'll extend this active record model. I'll lay in the table name always. I'll default what the column should be, probably an ID. And then this is basically an example of just showing that the two would be equivalent. So simple extensibility is made possible by these objects now, or extensibility this way. Now we can do some late static binding extensibility, taking advantage of this late static binding feature that was added in PHP 5.3, where essentially instead of writing that constructor over and over and over again, we can just say what the table and column are. Just do that, and then layer that other piece down another layer. So just a slight tweak on what we already had. But now with this, we've now allowed you, instead of your user having a constructor, just go ahead and set some static properties. But for anyone following along, performance here sucks. I mean, right now, everything we're doing, every time we do an interaction, we make a database call, and that's just retarded. Nobody actually implements active record like that. So the first thing we want to do is we want to buffer our reads. That's pretty trivial. Go ahead, we'll add a read buffer. We'll set it to false by default. In this case, we'll just say, okay, well, if there's a key, let's go ahead and load the stuff into the read buffer. We'll go ahead and put a get. We'll put a get in our get method. We'll change it slightly. Actually, ignore the fetch here. It's another bug in the slides. But we basically just we look in the R buffer, we dump that out. Of course, you want to do some stuff to check is set and things like that, but just for simplicity here, not doing that. But what happens if we never read a record? If I've got this R buffer being loaded in the controller or in the constructor, every single time that I initialize one of these, even if I don't end up reading from it, I end up making that call. So we've got a problem. And the way we solve that is a concept called lazy initialization, lazy read, lazy whatever. They've got a lot of different names for it. It's the same idea. Basically, again, we'll have that R buffer set false as usual. This time we won't put the read inside of our constructor. Instead, we'll go ahead and we'll implement this private fetch method. And this fetch method, we'll just say, well, if there's not a read buffer, let's go ahead and get that. And then we'll just go ahead and we'll implement our get to call that fetch and return the read buffer once we've actually sucked the data into it. And that basically allows us to, in the event that we don't end up reading the active record, we don't end up making a database call for it. Now buffered writes, not too different. The idea of a buffered write is right now with the update, every single time that I go ahead and I update something on that active record, I'm making a database call to do the update. But if I batch my updates, right, a lot of times a user submits a form that changes their profile. They've got 16 different fields that they've updated. We're going to handle that in batch. So why would our update just execute for every single one of those properties? We could say, okay, well fine, let's let the update method take an array, and we'll do it that way, pass an array. But if we want to use the object route of doing things, if we want to pass things in as properties, that's not the right way to do it either. And the right way to do it is just to buffer our writes, so we assign these object properties, and then after the fact we call update, and that finally sends it to the database. So now our set, we get rid of our database call. Instead of our database call, we just go ahead and stick it in a write buffer. With our write buffer, when we call update, we'll go ahead and we'll do this update. We'll go ahead and we'll move the write buffer into the read buffer if there is a read buffer. So this would be if the record has actually been read and then updated. We'll just go ahead and move stuff in, and then we'll go ahead and we'll clean the write buffer back out. So it's pretty simple, but it's just an easy way to handle caching all of this information. And then our read just changes ever so slightly. Our read now, in this case, what we're looking at is we're looking at the fact that it might be in the write buffer. If it is in the write buffer, we want to default to the write buffer. If it's not in the write buffer, then let's fall back to the read buffer. So just another step of complexity. And in fact, you probably want to get rid of that fetch call unless you're actually going to the read buffer. But just kind of a basic example. One more thing that's a problem right now is I might, right now, every single time I pull up an active record, I'm actually going to be creating a database query to initialize it. So another thing that's commonly done is we want to reduce the number of times we actually call that database. So we might do one database call that returns 100 records at once. And in that case, let's go ahead and create this other thing, this demand load type approach. And in this demand load, basically the idea will just be, if I've got the data, so I've done maybe a database call and I've gotten back a whole bunch of rows, I should be able to just push a row into an active record without having to actually let it go to the database. So an example might be, if you got the load, you just stick it in the read buffer. That's easy enough. And so that's kind of just a basic example of why this is useful. We go ahead, we do our select, we get all of our users, we do a for each, we loop through those, and we just load it in for each of them. And so now we've reduced our database queries to 1 for loading any number of different of multiple users. So putting it all together, what we've kind of talked about as far as active record type modeling for databases is, we've got our CRUD operations, we've got our magic setters and getters, we've got our read and our write buffers, we've got some lazy initialization and demand loading. Now this is just a toy, but it's a common pattern, and you'll see it in almost every framework out there right now is doing it in some way. Just a really simple, complete example that doesn't kind of have anything else. Just going to call that out as a potential link. Before I go on, though, I should just make real quick mention to an alternate pattern. The alternate pattern is basically that of doing an object relational mapper. It's a much heavier pattern for doing database interactions. Don't want to get too much. I'm not going to get into it really today, but it is just another pattern out there to be aware of, and you can weigh the costs and the benefits of it when you compare it with active record. But I find active record to be very simple, and that's why I prefer using it.
Is it more common to have like the actual ORM mapper is in PHP you'd see like most of the frameworks would use like something.
I actually don't get the feeling that most of the frameworks do. I really haven't felt, I would consider, some of them call them ORMs when I wouldn't necessarily say they are. When I think ORM, in PHP, the best example I can come up with is Doctrine. And it's incredibly powerful, great way of defining relations, and really hard to work with if you just want to get going quickly. What?
Extremely monstrous.
Yes, Doctrine is very hard to work with. People that do enterprise software, if they're ever going to touch PHP, they're happier to use Doctrine than not.
We used to have like a Propel as well, but it's kind of less. I don't see that much anymore.
Yeah.
But there was no actually pretty like any good like active pattern implementation for PHP, at least until recently.
Yeah, but there are a lot right now. I call that the one in the Evander framework just because I'm sourcing my own kind of work, just because it's a simple one that's well documented, whatever. But there are a whole bunch of them out there. I mean, even the Eloquent one, I would say, is more of a active record really than a real true ORM, even though it kind of trends that way. It's funny because the Eloquent ORM is actually almost directly modeled after Rails's active record. So I kind of find it funny that they switched the name into ORM when it's actually modeled after what Rails calls an active record. But in reality, I would say that's another very good example of an active record would be the Eloquent ORM. So Any other question on the database stuff before we just kind of briefly talk about files and cookies? Yeah.
Well, on the database, like especially in e-commerce, is very common. They use like the EAB pattern.
I'm actually not familiar with that one. The EAB pattern?
Well, it's it is element attribute value. So
oh, okay.
Yeah.
so
Yeah.
you kind of
Magento, install Magento and enjoy.
So it's essentially instead of like keeping everything in one row in the column, every single value is a separate record in the database. So you load and you can use a similar,
I understand what you're talking about. Yeah.
similar kind of we call it a profile pattern, but it's like very similar to active record.
Right.
You load the profile, which loads all these records.
You just load it in instead of loading it in this dimension. You're loading in that
write
dimension.
to it and it doesn't write everything to the database automatically. But when you're ready to dump it down, you just
It sounds like it'll work the same way basically as this, right? Exactly. The same sorts of things, the magic setters and getters, except you're going in multiple rows rather than in columns for it. Yeah. Okay. Then real quick, just in terms of objectifying CRUD in the file system, this one is less commonly done, but I think it is very useful. I personally would much rather work with files and directories as though they're objects, rather than just work with them as PHP-based library functions and then random stuff that people add on. Because it lets me say well, give me the parent directory model, or give me all the child file models. So it's very useful in some ways. So I would say that it's really not all that different from a database actually. So we've got some reads, we've got some updates, and we've got some deletes. It's all basically the same stuff. It's all CRUD. And same thing with directory. Although I'm not really sure what you do about updating a directory. Maybe that's rename, but it's something. But there is more to a file system than just CRUD. So I was just going to kind of throw up real quickly a few examples of stuff that might go in a file system set of models. I'm going to start with an abstract class that I would consider kind of a file system model. So be it a directory, be it a file, be it a symlink, be it whatever type of a node it is inside of the file system. Some common stuff that you might have on that. Some abstract things that vary depending on what you're talking about. So if you're talking about a directory, doing some of these operations like a delete may be very different than if you're talking about a file. But ultimately, you're going to want to make sure you provide these no matter. The benefit to modeling everything is now we can just pass models around for everything. So I can say, well, give me the parent directory, and I can actually return models of different types. So it's just kind of a nice pattern to work with. And so then, there's some file operations that you can add in. So, we got to implement the move, the copy, and the delete. And then just some other stuff we might do with files. Similar stuff for directories and symlinks. Honestly, I'm not really going to dig into this one, except to pose the question. Yes?
Just for everybody's benefit, you might want to mention the file system classes in SPL and the iterators as well as stuff.
I actually don't know too much about those. I didn't realize they were in there.
SPL 5, it's good stuff.
Oh, you want to tell us a little more?
Well, it basically does kind of that interface that you presented. You don't have to do anything.
well with the
Okay, ignore all my work then and go look at theirs instead. And only if they did what they did with Observer and went too simple, only then go back and maybe think about this. But otherwise,
How's
use
the
theirs.
documentation on SPL nowadays? Did they improve it?
It's better than it used to be. But they actually have a bunch of classes that encapsulate some different patterns and things that are as simple as
Observer.
double linked lists and a bunch of different things.
I knew they had double linked lists. That one's been there a while, but
in
yeah.
SPL, it's not as much as CRUD, as more how you traverse, they implemented a lot of iterators that are really useful.
Yeah.
If you because the common problem with dealing with the file system is not as much of accessing specific files as you just got this directory structure, and you need to walk through them,
Yeah, but the one thing I would point out with that is that I really do like the fact that if you objectify it, if you do turn all those nodes into objects, you're still walking it the same way. You may be calling a slightly different method to do it, but you gain a lot more freedom in some ways. I mean, you can implement an each then on it if you wanted to, and you could invoke the callback on every single thing in it. So there's all sorts of cool stuff you can do if you objectify it. But that really is my only real takeaway here is that try to objectify your file system in some way, because it is really cool to work with that way. And in fact, all these sorts of things, yes, PHP provides base functions for them, but when you start objectifying the stuff, like the output buffer is another one where, I mean, literally the output buffer I showed, I would just use the OB functions, but I wrapped them in an object, and then because I was able to extend that object, next thing you knew, I'd been able to add templating in seamlessly. So the object stuff is pretty cool once you really, if you really want to encapsulate everything. But do try to keep things light, because a lot of the objects, I feel like you definitely see way too much complexity over time. And then cookies, I'm going to leave that as an exercise for the curious, or for the less adventurous, I'll give you a link. So just kind of really easy example of cookies. But again, you know, you're basically just setting stuff like lifetimes and stuff like that. Why persistence objects? They are reusable, they are extensible, they're all the things that we've been talking about today, and they're very conducive to our mental model. And so that's kind of where I'm going to leave the persistence objects talk, but there are links in it. So if you go back to my slides and you ever want to look around, some cool places to start. So any questions on that before? Mm-hmm.
Well, one thing about the file system model that I saw there, which is what I see a lot of the ORM,
Mm-hmm.
is that it looks like that it encourages very expensive use cases. So one of the big flaws of, let's say, ORM is that some inexperienced people can intuitively do, like, you know, nested for loops or something, and it looks like a very logical
Right.
you know, bunch of code to write, unless you're smart enough to know that that's not there. And of course, with file systems, when you go deep within a path structure, you know, you have to read each one of those paths, and there's a bunch of I/O. And especially when you come up with like lots of files inside of one directory structure, then
Yeah. No.
and file systems can easily eat up all of your time.
Not only can they do it, but they usually do.
And so that methodology of abstraction, my primary fear is that it suggests those types of programming patterns.
Yeah, I think that you're right on that. I mean, I push like developers I work with towards active record more than ORM to try to break them from exactly that problem in ORM, and then we get into files. You are right, though. We are reading more on disk, and I think a well-written framework, for example, might actually go ahead and deeply abstract that. You know, deeply abstract out, say, caching of some of that stuff to avoid actually doing all those reads, but it starts getting really messy really fast. So yeah, it's not necessarily an easy thing if you play badly with the system. Say I did an each phone, say I implemented an each method, right? And then I go ahead and on that each method I do something recursive to walk the entire map. That's going to be incredibly ridiculous.
Well, I mean, like one of the big performance gains that you get for, let's say, databases is the use of, let's take Postgres, for instance, is to have an actual pointer that you can reuse, and you use cursors. And,
right.
And if somebody just uses cursors, then all of a sudden, like, the performance increases, quite a bit.
Oh yeah.
And so for file systems, you have very similar analogies. You've got directory pointers and all these other things, that you can then pass around and reuse again and again. Mm-hmm. And so, there's plenty of ways to optimize that. I haven't seen any of those. I was wondering if
I haven't worked much with it. Honestly, most of the stuff I'm working with isn't too heavy file system. I try to keep it out of the file system as much as I can. But yeah, no, I think I'd be happy to talk with somebody about that if they want to talk more afterwards. But yeah, I don't have much familiarity with all the file system stuff. Okay, then just one closing section, just where from here. So, I kind of would be encouraging here, one thing when you think about designing frameworks, you really do want to stay out of the way. So some of the patterns I've talked about today may help that. Some of them may not, but ultimately you're trying on the whole. Don't get more in the way of your developers than you have to. And don't force them into one way of working. If they want to change what they're the way something works, let them. Think about ways in which you can build your framework in such ways that you can actually let developers change the way the whole thing executes if they feel like it. In recap, we talked about autoloaders for the seamless substitution. We talked about observable execution, how you do plug-and-play extensibility, just easy ways to add objects that can handle all sorts of different events in your application stack. We talked about routing approaches, so when you would use it implicit, explicit, or some sort of a hybrid, that implicit with explicit support. We talked about output buffering, so how different ways you can encapsulate output using the output buffers in PHP. We talked a little bit about persistence layers. One thing I wanted to bring out was micro frameworks. It's kind of a cool trend that's going on recently. The idea is you focus on doing one thing well. And they're very, very common in some language systems. Ruby, Node.js, Python. You know, we got a lot of really, really great libraries and a lot of other languages that'll let you do this. But with PHP, we didn't have that for a long time. If you look at most of the frameworks maybe 4 or 5 years ago, none of them are using a whole bunch of small assembled micro frameworks. They're just using all of their own stuff. But they've been made viable with Composer. And this is not a talk on Composer, but I would highly encourage you, if you have not used Composer, check it out. It is awesome. And it really does make this very easy, especially as more and more micro frameworks spring up. The fact that you can go in and you can take Symfony components and take Laravel components, and you can just mix and match the pieces you want, it's great and should definitely be encouraged. And so I really like Composer. And so Laravel 4 is a prime example of this. Evander 2, some stuff we're tweaking on right now. We're eventually going to be doing the same sort of thing, just doing micro frameworks, and in a way just providing different sorts of components that would be useful to somebody, not necessarily in some broad assembled piece, but literally just for the sake of that one component. And with that, I would like to thank everyone for their time. I know it's late, and I would like to ask if there are any questions. Silence.
Questions? Well, I was actually like, I have a lot of them, but I probably can leave it for offline discussion.
Our biggest question would have been around the observer and attach
Mm-hmm.
pattern. You know, you talk about doing the auto loading of classes and the various classes attaching to the various events.
Right.
But in certain cases, you know, the way you showed it, it always ran over the loop in the same order. How would you deal with situations where maybe in this edge case, one of these observers needs to act out of order above another observer that needs to go behind it, but only in that edge case? So maybe in you know, before buffer, we need to catch that and do the reroute from your dynamic routing example, but only if we're in that one case. Whereas, you know, they're typically stacked.
Okay, you're right. So it is implemented that way, and it is pretty hard. One common way that's done, although I would actually highly discourage it here, would be precedence ordering. You know, you're giving things where you like some sort of priority key.
So like
You've now gone discrete. So how do you define one weight against another? It's like nicing a process. It doesn't really help. So the other way to do it, in a way that I think makes more sense, although it adds complexity, is that you actually focus on attaching very few things to any one thing. So you don't attach everything to your application. You might attach your response to your application, but you might attach your template handler to your response, and then let your response fire its own events that do things. So you can pull pieces out, so different things attached to different things. Another common pattern for events that's done is actually to have before and after events that in many ways work the same way that something like a priority heap would work. They're useful in cases where you're not defining individual callbacks, so you're not saying run this on initialize with this priority and run this on execute with this other priority. They can be useful just to say, well, since my app isn't that big and I know the framework doesn't do anything outside of the actual event names, anything I put in after or before is up to me.
So in that edge case, you would say instead of just running through render, you would say before render.
Yeah, and that's
this thing, and in that edge case, it would catch it and say,
yep.
Okay, before we do anything, we need to run this.
It's another option, and it's an option that works for a lot of people. I've seen a lot of stacks that are implemented that just have that extra set of events.
Right. Okay.
So just different approaches.
Yeah.
Other questions?
For your intro, it seems like you accomplished exactly what you set out to fix. What happened along the way that kind of led you astray?
What led us astray initially was we wanted to build a framework that did everything. We wanted to build a framework that gave somebody an environment that they could work in, that we knew the right way to do things. But this did not fit our model, our business model. It was kind of just, honestly, it was an oversight in the difference between, being a technologist and being a businessman, was seeing the difference. And we're telling our developers that we're going to leave them the ability to be independent and free, but then we're going to give them a system that is so great it's going to tell them exactly how to do things. And the reality is, no framework that we're producing for that sort of a crowd. No framework we're producing for kind of broad readership, you know, for the people here, right? I couldn't make a framework that told you how to do everything that appealed to everybody in this room. There's just no way. And that was basically the problem we ran into. And so our shift was really, well, we need to rethink this problem in such a way that things are brought to a level where somebody can always swap in whatever they want. And it's kept lightweight, and the components are kept very loosely coupled. And so it is easy enough to do that. And we cut down on the documentation. We do make it possible. With the framework we actually ended up producing for that, we made it possible that if you wanted to, you could actually use the old school individual script per different function you do model. You didn't even have to use MVC if you didn't want to. And so that was the approach we had gone with on that iteration that finally worked and that really did stick. Because what a lot of our developers found was they'd go in there, they'd start working with the base of the framework, and they're like, okay, yeah, this is chill. I'll use the MVC, I'll use the active record, it works. And then they'd get to some edge case where they'd be like, well, I need to do a deep array comparison against these things. You know, they'd write their own, and it might work, it might not. And then somewhere along the way, they go, oh, wow, actually, sweet, that's already here. We can just use that. And, you know, then they just start, it becomes part of a learning process. And they could decide whether or not they wanted to. And by keeping everything loosely coupled, keeping everything small and modular, it's really easy for them to decide which pieces they wanted to use, which pieces they didn't, to crack it open and see how it worked. And it's just a very different way of writing frameworks in some ways than you'll see in a lot of places, and a lot of, especially the older frameworks, where there's just, you know, it's very complex to understand the cycle that an application goes through. So we just went astray because the technology didn't fit the business model, and that happens. And so we threw away all the work and started again, right? It's all the fun part. Yes?
So it seems like this is all about creating your own framework, obviously, as opposed to using one that
Right.
exists. How often do you find yourself, or do you think people, developers in general, find themselves having to create their own versus use? Because, you know, that's one of the things that I'm wrestling with right now.
Right.
There are some really, you know, the popular frameworks out there. There's Zen, there's Ignite, there's Cake, you know, all this stuff. And I don't know how to use any of them.
Okay.
So I'm trying to decide where to spend my time. And that's how I ended up trying to design my own, because I felt like for the stuff that I want to do initially, at least, you know, I want something that I know how it works, as opposed to spending 6 months learning how to.
Let me answer that question actually by changing language systems. So in Ruby, one of the big frameworks they use is Rails. Very powerful, does pretty much everything under the sun you could ever want. Very cool framework. But it is also very heavy. It's got a lot of stuff in it. You have to understand it all. And it is very much like what you might call an old school, you know, like these old school frameworks I'm talking about. But one of the nice things about Rails is it's actually not that. Is that I can actually say, I have no interest in the entire way it handles controllers or any of that. I don't want any of it. I'm going to use this other router. I'm going to use this little tiny tool called Sinatra. The book for Sinatra is 70 pages long. It's perfect. I'm going to use Sinatra, but I love the way Rails handles the database. So I'm just going to include this other gem, this active record from Rails, and it'll work. And the reason that works is because everything has been chunked up as these micro frameworks. That active record doesn't require Rails's, you know, application stack. Now, in PHP, up to a few years ago, we weren't there yet. We hadn't gotten anywhere close. We were still at this phase where everything, it was, well, okay, do I use this framework or that framework? You shouldn't be asking that question. The question that you wish you could ask was, well, where should I get my autoloader from? Where should I get my active record from? Where should I get this from? And we're still not quite there yet, but we're getting a lot better. And a lot more frameworks right now are transitioning towards that model of putting a whole bunch of small modules out via Composer. And when you pull their skeleton down, what you really pull down is a Composer file that says all the stuff that you're going to pull down into their vendor area. And so right now, I mean, the challenge is if there is some use case you have that a framework fits perfectly, great. If there's not, figure out what it is you need to do. Maybe there's a framework that does 90-95% of it. An example would be like Laravel. Let's say I had an app that fit Laravel's case perfectly, except I needed implicit routes, not explicit routes. My developers, for some reason, this was a business need. The easiest way to get around that, well, in Laravel, it's easy. I can just hack it in because I can just say, well, pattern match star, and that's trivial enough. In other cases, the frameworks are less nimble. So some frameworks are nimble enough that you can just get in there and you can hack away pieces and get it to do what you want. And then as we start getting towards micro frameworks, we're getting in a whole new world of being able to mix and match. And that I would like to hope that within a year or two, you don't have this question anymore because honestly your framework is just a big composer.json file that says what it should suck in. And then you just kind of have, some objects that kind of, fix the little fray along the edges. But yeah, it's a hard question. I find myself often writing frameworks because I need very little out of most of these frameworks. Most of these frameworks have way too much in it for me for what I'm trying to do in a given use case. So a lot of times I find myself implementing. But with stuff like Symfony and Laravel 4, we're getting a lot closer. Other questions? Cool. All right, well, I hope that was